I figured it was time to give you an update on where things are at with the tractor conversion project. This last month or so I've been working on getting rid of extra components and extra wiring in the original leaf harness and such so that I can reduce some of the bulk and some of the extra things that need to go into a box on the tractor. So what I have gotten rid of, I was able to get rid of the brake pedal. I still have the accelerator pedal in here, and in a second I'll show you why I'd like to get rid of that. It's sort of buried in here, but yeah, there it is. But the VCM gets pretty unhappy when that's removed. In fact, if I remove it, I turn the system on, I can't even get the system to turn off. And even the high voltage contactors are left on in that state, such that unhooking the 12-volt battery doesn't even shut the system down. I have to disconnect the power coming off the inverter over here on this side to get it to shut down. So anyway, I think it's acceptable to leave that accelerator pedal connected. The big accomplishment that I've had is being able to get this Arduino teensy to be a man in the middle. I sort of covered up all the wiring that I did, but I spliced into the CAN bus coming from the VCM going to the electric motor and inverter, so I can intercept the torque request signals coming from the VCM and send my own request in place of that. And I'll show you what that accomplishes. So here I'm going to push the power button. It requires pushing it twice because it doesn't actually detect the key. The key fob is sort of taped to the side of the receiver there on the power button. And you'll see that it comes on, gets into drive mode. And if I stick it in drive, which is there, see it gets into drive D. And what I have here is, so now instead of using the accelerator pedal, which actually doesn't work right now because I'm not letting those signals go through. It's probably a little hard to read the display, but I have a potentiometer here that is connected into this Arduino, and as I increase the potentiometer, you'll see the target RPM going up and the actual RPM following. You can probably hear it. And over here you see my speedometer, which is being controlled currently by another microcontroller. Yeah, that guy over there. Eventually I'll get this Arduino to control that as well, and then I'll just have one thing to deal with. But I'm having trouble with the CAN FD controller that's on this teensy. It's not sending signals, so I'm gonna have to, I don't know if I did something to make that not work, but it's not even working with the example software they supply with it. So anyway, so yeah, this software on this Arduino is implementing a PID algorithm for maintaining speed. So it'll act as a governor or a cruise control. So whatever target RPM you set, it'll try to maintain that. And I need to do some more tuning, I think. See, as it's increasing the torque to maintain that RPM. And it's a little slow getting right to it, depending on how fast I increase it. But there's tuning I can do with that algorithm, and right now I have it to where it's limiting the torque quite a bit, especially when you're reducing the speed. See the TRQ value there is how much torque the torque request is giving. I only go down to a -5 torque request. I forget what units those are, Newton meters, something. So yeah, that's where I'm at. I think I'm going to next install the motor into the tractor and hopefully be able to have enough wire length to hook it up out there with this tray and just run it through its paces, make sure the hydraulics all work and that sort of thing. Right now, as far as cooling goes, I just have it recirculating the antifreeze in the reservoir that it has. I'll probably leave it like that for a while until I actually get things set up. Yeah, so hopefully you find this interesting. I'll take another one once I get the motor in the tractor. Thanks.